So now that we have some of the basics behind us, let's go back and take another look at that ratings counter program that we wrote back in Lecture 2, way back in the beginning of the course. We're going to break this down and try to understand a little bit more depth what's going on here. So if you open back up the Scala IDE, you should have this there still. And again, if you want to run it, you can go to the Run menu here, go to Run Configurations, make sure that ratings counter is selected here, hit Run, and off it will go again. And just to remind you what this script does, it's actually going through 100,000 real movie ratings and counting up the distribution of different rating scores. So you can see here we have 66,110 one-star ratings, 21,000 some odd 5-star ratings, etc., etc. So let's dive in and understand more about how this actually worked. Not a whole lot of code, so just keep this up and follow along with me, and we'll go through it one line at a time. So let's dive into this code that counts up ratings by their rating value in a little bit more depth and understand what's going on at a deeper level, shall we? So let's take a look at the first few lines of code here. First thing we're doing is declaring what package this code lives under. So we just say package com.sundogsoftware.spark. Remember, that's the package name that we settled on while creating our project back in Lecture 2. And that's just a unique way of segregating off our code so it doesn't collide with other people's libraries. Next, we'll import the specific libraries that we need for this script. So we're going to import all the stuff from the Spark library that we need, specifically the Spark context object, and also we're going to import the log4j package because we're going to do some games with the log level. And that's actually the next line in the code there. I'm not going to go into too much depth on that, but we're just using log4j to say only print out error level messages. But the first bit of Spark code that we're going to run is this. So remember, the Spark context object is what we use to create our RDDs. So it's kind of the first thing that we need to make. So this is saying that we're going to create a new Spark context object. We're going to call it SC, which is an immutable Spark context object. And this local bracket star thing just means that we're going to be running it on our local machine. It's not going to be in a cluster at all, but this star indicates that we can actually use all of the CPUs, all the cores on our CPU, to actually distribute that locally if we need to. So if you do have a multi-core CPU running, it can actually still distribute it across those cores. And this is just a name for the Spark context itself. We're going to name it ratings counter, and that's just so that if we're looking in the Spark UI for progress on the job, we will know what to look it up under. So that will label this context in the UI. This job runs too quickly for us to actually do that, but later in the course we'll look at an example of doing that. So what's going on? First thing we do, we take that Spark context object we created and we call text file on it with a path to where the movie lens 100K ratings dataset lives. So the u.data file is what contains the actual ratings data, and it's going to import that one line at a time into a new RDD called lines. So lines is a dataset where every row contains one row of the input data that's in u.data. What does that actually look like? Well, here's a little sample of what's in that file. So the format here is basically user ID, movie ID, rating, and timestamp. So the way to interpret each line here is, for example, user ID 196, watched movie ID 242, rated at 3 stars at this time, and so on and so forth. Okay, so we're importing in our raw data that we're starting with here, and it lives in an RDD called lines at this point. Now the next thing we want to do, and this is generally good practice, is throw away all the information that we don't need. A lot of the time and resources that a Spark job requires, it depends on how much data it has to push around. So the sooner you can get rid of data that you don't need, the better. And that's what we're doing here. Basically, we're calling map on that lines RDD to transform it into a new RDD called ratings that parses out each line of the lines RDD and only extracts the field that we care about, that third field, which is the actual rating value itself. Remember, our end result is just the breakdown of how many times each rating occurs. So we don't really care about the users or the movies themselves or the timestamps. All we care about are those rating values. So let's take a look at what's going on here. We're calling the map function to transform that line's input RDD and passing it this function to transform it with. So basically this says take every individual line, call it X, convert it to a string, split it up into a list based on tab characters because I happen to know this file is tab delimited, and then extract field number 2 from that list. And remember, we start counting at 0, so field 0 would be the user ID, 1 would be the movie ID, and 2 is the rating. That's the one we care about. So basically this function gets applied to every line of the input file, and we get back a ratings RDD that will contain something like this, where only the ratings survive. So now we have a ratings RDD where each row is just the actual rating value for each individual rating. So in this example, we start with this, we end up with this, just a list of 3, 3, 1, 2, 1, because those are the actual rating star values for each row of input data. With me so far? Okay, don't be afraid to pause and go back and rewatch things. This is all very important to understand. We're going through the real fundamentals of Spark programming here. So now what? Well, the end result we want is the count of each rating, how many times it occurs. And Spark has a handy function called count by value that will do that for you. Now remember, count by value is an action. So when we call this, it will actually cause Spark to go off, compute its directed acyclic graph, and actually start chugging away on all the data and distributing it if it can. And this is what we end up with. So count by value returns, takes an RDD, but it gives you back a Scala map object, where basically it maps identifiers, values, to how many times it occurred. And in this example, we're starting off with an RDD that just contains values of ratings themselves. Count by value will give us back a Scala map that we can then do whatever we want to, where it just maps values to how many times it occurs. So basically we now have at this point an RDD that we perform an action, count by value on, and returns Scala data in just a map format. For example, rating 3 occurred twice, rating 1 occurred 2 times, and rating 2 only occurred once in that data. Okay, makes sense? We have 2 3s, 2 1s, and 1 2. Now, the last thing we have to do is just display our results in a good way. So the first way we're going to do that, we're going to convert our result map to a sequence, which is something we can actually sort. And we're going to sort that by the first field. So this is just saying, take my results map, convert it to a sequence, and sort it by the actual rating value. And then we can take that resulting sequence, call for each on it to apply print line to each row. And that's what actually prints out each individual row of the results in sorted order. And our final results are rating 1 occurred twice, a rating of 2 occurred once, and a rating of 3 occurred twice in this very simplified example. Makes sense? It's not really that complicated, but it does illustrate just how simple it can be to perform big distributed operations with just a few lines of code in Spark. So that's pretty cool stuff. It's really just that easy. So if you need to watch that again, please do. If you want to go stare at the code some more, please do. I encourage you to do so. Play around with it. And let's talk about in a little bit more depth as to what's really going on underneath the hood. We'll do that next.